Welcome back. So, what sort of impacts do tsunamis have? I'll give you a hint, it's a lot of bad ones. Let's talk about it, shall we? So, with tsunami, there's two different hazards. We have the primary hazard. So, the primary hazard associated with tsunamis is the initial inundation of water resulting in flooding, erosion, shortening the coastline, debris erodes landscape, destroys human structures. So the water rushing in is the primary hazard associated with a tsunami. The secondary hazards of a tsunami, as with a lot of these other things, oftentimes cause a significant amount of damage on their own. Some secondary hazards can include fires. Ruptured gas lines could cause fires. Contaminated water supplies. As that water floods in, you can contaminate any surface water supplies. Wastewater treatment plants, the plants that treat wastewater with poo and pee in it, are often at the surface with some things. So as that water rushes over, you're picking up all that contaminated water, putting it elsewhere. Rotting animal carcasses, cattle, humans, as things are dying in water, it can contaminate water as well. So water contamination could also lead to issues. People drink contaminated water and they can get sick or die from that. Maybe not from the tsunami itself, but secondarily from something the tsunami affected. Disease, again, coming in contact with polluted water or polluted land for whatever reason can cause disease. So it's interesting that a tsunami can be a secondary hazard of an earthquake, but a tsunami itself also has a primary and secondary hazard. What are some benefits of tsunamis? With each of these hazards and disasters we'll talk about every week, I always bring up benefits. In this case, for tsunamis, not too many. You can maybe throw a few things out there. It may bring in nutrients and different sediment from the ocean that are needed by soil. So maybe if a tsunami occurred in an area that there's no one living and it rushes in and can create better and fertile soil, maybe for people to farm in the future, assuming no one lives there now. May bring in sediment. It can wash away sediment in some places, take away sand and dirt and shore in some areas, but maybe deposit more in other areas that may need that. Redistribute organisms and build new ecosystems. So, as a tsunami rushes in on land, maybe there's a river flowing into the ocean, and you got some fish here. For some reason, that tsunami would pick up those fish, push them way inland, miles and miles inland, to create a new pond and new fish within that new pond. So it can create possibly new organisms and ecosystems, but along the way would obviously do some damage. So, it's hard to think of some benefits, but there can be some, mostly to nature as we know it, and maybe not so much to humanity. Can humans cause tsunamis, and if so, how so? We cannot prevent or control tsunamis. Human activity does not affect frequency or the magnitude currently, really in any way. But what is an issue is we're starting to live, work, vacation in areas that we probably shouldn't. Areas that are prone to earthquakes and tsunamis. So how we're making it worse is we're not necessarily doing anything to create more tsunamis, but we're living right on the shore. We want that house. We want that vacation right on the ocean. Well, things happen. All right. So the increased use of shoreline increases the consequences stemming from tsunamis. So we can really only come up with, because we can't prevent them, we can't stop them, we can only come up with strategies to minimize tsunami hazards. Things like detection and warning systems. We can't stop the tsunami, but if we have enough warning ahead of time, maybe we can get the people away from the coast. Structural control, so how we built structures to prevent tsunamis from coming into an area, or how we build stronger buildings to withstand the destruction from a tsunami. Tsunami's still going to happen. How can we build kind of for it? Land use, maybe not necessarily putting cities right on the coast, maybe putting them inland a little bit. Education, letting people know what tsunamis are, what to do in case if there's a tsunami, some warning signs that there are tsunamis, etc. And if there is, and a warning system, and knowledge, and a way to get out, have everyone understand the evacuation plans. There are set evacuation routes, etc. So again, around the globe, there are tsunami warning systems. Prior to the 2004 Indonesian quake and tsunami, there was none in the Indian Ocean. Now that has changed. One of those warning systems is called DART. It stands for Deep something. It's on the next slide. In any case, let me explain how it works. So around the ocean, there are these buoys. So these things that float on top of the water. This isn't what detects the tsunami. It's actually what's on the ocean floor. So this little recorder on the ocean floor detects microscopic small little changes in pressure as well as temperature. When more water goes overhead, it's going to feel more pressure because there's more weight above it. So you got more water, tsunami wave rolling through, because this wave is rolling through, it's going to feel more pressure, and that more pressure will then trigger a signal that's sent to the buoy, and the buoy has the antennas to send it out elsewhere. That's the warning system. So that's how it kind of works. So the detector is actually on the floor of the ocean. It just sends a signal to the buoy sends it to satellites. And these can be up to about 3.7 miles below the surface of the ocean, which is absolutely just breathtaking and fantastic thing about the technology that went into creating some of these. You can see the red dots are the tsunameters, so the tsunami warning system sensors. But there's a number of different sensors, seismograph stations to detect earthquakes. Earthquake occurs, maybe that might trigger a tsunami. Tidal stations as well to measure depth of water, height of water, I should say, as it comes in on land. But these deep ocean tsunami warning system is what is going to be the biggest benefit. So again, DART stands for Deep Ocean Assessment and Reporting of Tsunamis. Got it. Again, detects changes in seafloor temperature and pressure, enables instant, accurate tsunami forecasts. Typically, it will record data every 15 minutes when there's some sort of event that picks up, and every 15 seconds, pressure and temperature is recorded and sent to satellites. So this whole process started in 2000, but it really ramped up in 2004 after the Indonesian tsunami. So, again, this is in 2004. This is the day after the tsunami. So you can see there's really only 4 sea level gauges, which measure the height of sea level, no tsunameters. 10 years later, you can see some of these tsunameters in place, a lot more sea level gauges around to measure the height of the ocean right along land, but the tsunami detection system did come into play, and it's ramped up even more. So these are all, again, tsunami detecting buoys, so a lot along the Pacific plate boundary, again, very active area through South America, North America, Alaska, into Asia, and that's the U.S. DART system, but other countries also have other systems as well. India now created their own, Australia created their own, but they all work together and they all communicate with one another. So what it shows you, what kind of a read would look like. So this is 21413. So this is an example of the 2011 earthquake that occurred in Japan, which happened close to the coast, but at this 21413 station, you can see all of a sudden this big spike. All right, you can see this big spike that occurred. That indicates that the water depth increased, so we had this tsunami wave rolling in. So we can see that data very quickly, real time. 2010 Chilean earthquake. Again, you see this spike with station 32412. In both these cases, these are away from the coast, so deep ocean. So a tsunami, as it's rolling through the deep ocean, might not be very tall. If you look here, the sea level changed. Let's see, 4,325.6 meters to about 4,325.82 meters. So it rose, what was that, maybe 22 meters, which is 22 centimeters. So that detection system was able to pick up an increase in sea level by about this. So in the deep ocean, where the tsunami is moving very fast, you're going to get a little swell. It's really when these things get to shore, they slow down, they stack up, they become these huge tsunami events. So One way humans can kind of impact or lessen the blow of tsunamis is detecting them, having some sort of warning system, alerting people something might happen. We can also have control over the buildings that we build. So the designs of buildings. How do we, design buildings, houses, small buildings, to withstand these tsunamis? Because most houses and small buildings, they're unable to withstand even 1 to 2 meter waves. So that's, 4 to 7 feet wave, let alone something that's, 100 plus feet tall. Larger structures tend to be engineered a little bit more bulky, heavy. They're codes to build certain buildings. So they're kind of built to withstand some of that destruction and damage. But maybe how do we do that even with small buildings? So how we build buildings can help. Hawaii has special requirements in tsunami zones, but most areas of the world don't. Think Indonesia. Instead of the buildings themselves, maybe creating seawalls, large walls to prevent tsunamis or kind of redirect tsunamis, hopefully, if they're small enough, just to not allow the tsunami to move inland. But how high do you build it? It also gives a false sense of security. In the 2011 Japan earthquake, there was tsunami walls that were around, in one area, 30 feet high, but the tsunami was 32 feet. Well, bummer. So it's going to go right over and then destroy that seawall. So how high should you build it? Kind of gives you a false sense of security. So building structurally, very strong foundations built high to withstand a tsunami. And this is kind of an interesting little condo house. And I forget where this is located, but you can see, maybe some ocean inlet bay right there. Nice little modern area. But what's cool about this whole structure here is that in its resting position, there's some floors below ground. But if a tsunami occurred, some sort of flooding event occurred, the whole structure actually floats. So as long as the tsunami isn't high enough, it can still float kind of within that confined structure. And then when the tsunami goes away, it kind of sinks back down. I guess the big issue is if the tsunami is too big, it just raises and your house floats away. Seawalls. These are some seawalls in Japan. For reference, look at this person versus how big this wall is. And these walls are all great, but again, false sense of security. What if the tsunami is just 1 inch higher than this wall? It's going to go over, probably completely destroy the wall. That's what happened a lot in the 2011 Japanese quake and subsequent tsunami. That's why 20,000 plus people were killed around Japan. So it was a disaster, so these were in place. So in some places it was beneficial. So again, lessening, stronger infrastructure, lessening the blow of these tsunamis. So about 20,000 people killed in this event versus the 230,000 in the 2004 Indonesian quake and tsunami. So what do? If you feel a strong quake, leave the beach if you're anywhere near it or any low-lying coastal area. If the ocean recedes, run. Go for higher ground. The time between kind of waves of these tsunamis can be hours. So even if one kind of tsunami wave rushes in and then kind of pulls out, there could be another one coming back in, even bigger and even bigger. So it's not one and done. If there's a watch or warning issued, don't go down to the beach to watch. Get out of town. If a wave's arriving, no time to go inland, find a strong, high building. If all else fails, try something. Climb a tall tree, a strong one. If trapped in the water, look for something to use as a raft, but it's probably not going to be going too good. If you got a 45-foot tidal wave coming at you, that's about it. So the big ideas, the 4 tsunami triggers. Tsunami formation in 4 stages, both in section 1. The risk zones around the world and the U.S., and the impacts on society, both good and bad. All right. That brings us to the end. So we'll stop there. Make sure you're working on that Unit 4 assignment on tsunamis, focus on the 2004 earthquake in Indonesia. One more thing to add to that super secret code. I want you to take that code that I gave you previously, divide it by 2. All right, so the code that I gave you, take those numbers, put it in a calculator, and then divide by 2. That's actually going to be the answer you'll need for the assignment. That is your solution to the super secret code. Until next time, I'll see you.